Okay, class, no noise. Chem 101, Monday, today is 20 what? 25th. Today is 25th of March. Chem 101 class, we're looking at HESS law under thermodynamics, and we want to take this question. So let's go with the question again. So the following data was generated by an industrial chemist during the production of nitric acid. The following data was generated by an industrial chemist during the what? Production of nitric acid. Now class, look at the data on the board. We have 2NO plus O2 to give 2NO2. The enthalpy change minus 216.00 kilojoules. Minus 216.00 kilo. Yeah, minus 216.00 kilojoules. Then we also have 2N2 plus 5O2 plus 2H2O to give 4HNO3. 4HNO. Enthalpy change here is minus 346.00 kilojoules. We also have N2 plus 2O2 to give 2NO2. Enthalpy change is 298.00 kilo. Class, we are now asked to calculate the enthalpy change those in FOS. The lecturer says you should always write your assignment in a size book, right? That when it's time, you will collect it. Good, no problem. So on Friday, we'll be using Friday for those. That we did last week, right? On Friday, we'll use it and be solving it on Friday. Now, let's not allow assignment to make us stop us learning our normal learning. So on Friday, we'll be using that for assignment time. Calculate the enthalpy change for the reaction below. Calculate the enthalpy change for the reaction below. 3NO2 plus H2O to give NO plus 2HNO3. Class, as usual, when given a yes no question, you'll be given 3 equations and the enthalpy changes. You'll be given 3 equations and the enthalpy, you can see this equation and the enthalpy change, this equation and the enthalpy change, this equation and the enthalpy. You will then be asked to calculate the enthalpy change for another reaction. Class, this guy, we are not giving the enthalpy change for this guy. How do we get the enthalpy change for this particular reaction? How do we get the enthalpy change for this particular reaction? This 4th one. Class, when asked to calculate enthalpy change for a particular reaction, this question falls under HESS law. HESS law of its summation. Class will find out if these 3 reactions, notice that these 3 reactions, we have been given the enthalpy changes for them. We're going to find out if these 3 reactions can be added up to give this particular reaction. If not, We're also going to find out if there's something we can do to any of these reactions to make them look like this reaction. If there's something we can do, we'll do it. Class, we are at this point now, we are trying to favor this particular reaction. We are trying to favor this particular reaction. Class, who is the first person in this reaction? Is 3NO2. Go to these three equations and look for NO2, 3NO2. Where do we have NO2, class? We have NO2 here, we also have NO2. Class, the first thing that is wrong is that our NO2, they are occurring on the right-hand side, right? The NO2 here is on the right-hand side, the NO2 here is on the right-hand, but the NO2 we have in the main question is on the left. Is on the what? So it's clear that something must be done to NO. Let's move over to H2O. H2O is on the left here, class, you can see. Where can we find H2O in these three equations? The second equation is also on the left, right? But class, the H2O on this second equation is occurring twice. But here is occurring once. Are you seeing it? Something must be done to this H2O to make it look exactly like this H2. What can be done to this H2O to make it look like this? We're going to divide by 2. So that it can also be occurring once. Right? But if you say divide H2O by 2, is it only H2O you're going to divide? No. Anything you do to H2O, you must do to everybody in this equation. So we'll divide the whole equation of equation 2 by 2. We're going to divide the whole of equation 2 by... So class, we'll say dividing equation 2 by 2. We have, divide this guy by 2, what we have? N2, right? 2 divided by 2 cancel out, N2 is remaining, right? Plus 5 over 2O plus 2 over 2, 2 cancel out, plus H2 to give 4 divided by 2, 2HNO. Class, when you divide a reaction by 2, what happens to the enthalpy change? Also divided by minus 346 divided by 2 is minus 1 minus 173 kilo minus 173 kilo. Class, what we just did to this equation is to suit this H2O. Class, NO. Let's do, where's NO in this equation? Where can we find NO? NO is on the left, right? But in our main equation is on the right. What do we do? Class, this NO must come to the right. It must come to the... It must not only come to the right, class. It must be divided by 2. Because my NO here is occurring once, but the NO here is occurring... So I must divide it by 2 so it can be occurring once. And not just divide by 2, switching to the right, because my NO here is on the... So we'll say reversing. Where's NO equation 1, right? Reversing 1 and dividing by what? 2. We'll reverse equation 1 and divide by 2. Class, why are we reversing equation 1 again? So that this NO can be on the right hand. Why are we dividing by 2? So that NO can occur once, because NO is occurring once here. So reversing 1 and dividing by 2, we have NO2 will now come to this side, right? But it will not be 2NO, because dividing by 2, 2 cancels 2, right? You have NO2 to give, divide this guy by 2, you have NO plus, divide this guy by 2, you have 1 over, because there's an invisible 1 here, right? 1 divided by 2 will now give you 1 over 2O. Class, when you divide an equation by 2, what happens to the enthalpy change? It is also divided by, so minus 216 divided by 2. Oh, it's no longer be minus, we reversed. We reversed, it will now be Anytime an equation is reversed, the enthalpy change is also reversed. Please take note. Anytime an equation is reversed, the enthalpy change is also. So 216 divided by 2. 108 kilo. And we have sorted out NO, right? We have sorted out N. Class 2HNO3, has it been sorted out? Class indirectly has been sorted out. Because class, remember when we divided this equation 2 by 2? This guy was divided by 2 and he gave us 2HNO3 now. So HNO3 is now 2 here, are you seeing it? So he has been sorted. So this is sorted out, this is sorted out, this is sorted. It remains this class. This guy is 3NO2. We need 3NO2 on the left hand side. So far we have only one NO2 from our rearranged equation. Class, if we reverse this third equation, class, if we reverse this third equation, it will bring 2NO2 to this side. It will bring 2NO2 to this. And by the time it brings it to this side, 2 plus this 1 makes it what? 3NO2. And can give us 3NO2. Class, let us reverse equation 3. Why are we reversing equation 3? Because NO2 in the main equation is on the left hand. So this NO2 must come to the left. Must come to the... If we reverse this equation 3, we are going to have 2NO to give N2 plus 2O. Class, what happens to the enthalpy change of a reaction when the reaction is reversed? The sign will change, right? Currently it is positive. It will change to what? Negative. So my new enthalpy change, please show it. Show this, enter where my marker is showed. Minus 298 kilo. Class, the last thing we must check out for now. We must now confirm these 3 new equations we have. If we add them together, will it give us our desired reaction? We must check. We must. These 3 new equations we have, if we add them together, must it give us our desired reaction? If it gives us our desired reaction, class, then we are good. Do you know why? If we can confirm that these 3 equations can be added up to give this our desired question, remember we are asked to find the enthalpy change of this question. If we confirm that these 3 reactions can be added up to give this reaction, we can then add up the enthalpy change of these 3 reactions to get the enthalpy change of this reaction. That's why it is called HESS law of constant heat summation. Summation means add up. So according to the HESS law, if you have 2 or more reactions with the enthalpy changes, and these 2 or more reactions can be arranged and added together to give a desired reaction. Class, the enthalpy change of these 2 or more reactions can also be added up to give the enthalpy change of the desired reaction. Class, these are the 3 reactions and the enthalpy changes. And we have to find the enthalpy change of this reaction. Class, we've tried to rearrange these 3 reactions to look like this reaction. If we succeed in doing that, we got these 3 reactions. Class, we now add up the enthalpy change of these 3 reactions and to give us the enthalpy change of this reaction. That's what we do in HESS law of constant heat summation. But we must confirm if we are correct. Let us confirm if these 3 reactions can be added to give this reaction. Class, how can we confirm? We are going to add up these 3. We're going to do that now. Adding up these 3 reactions. I believe we already have this question, so I can claim this side. Class, when adding up 2 or more reactions, what do? Add up the left-hand side to the left-hand side and the right-hand side to the right-hand. Please help me, flow with me. Who are those on the left, class? N2, yes. Plus 5 over 2 O2. Class, before we finish, is there any O2 here again? No. Plus 5 over 2 O2, yes. Plus N2, NO2. Where is H2O? Okay, plus H2. Thank you. Class, NO2 plus 2 NO2 is what? We have NO2 here, we also have NO2. 1 plus 2. 3 NO. Are we done with those on the left? Plus who again? Who's on the left again? We are done. 1, 2, 3, 4. Let's go to the right. Let's go to those. Who are those on the right? 2HNO3 plus plus NO plus class half O2 plus 2. Half plus 2 is 2, 1 over 2. 2O number 1 over class O2 and O2 are here, right? Half plus 2 is 2O number 1 over same thing as 5 over 2. Same thing as what? 2O number 1 over 2 is same thing as 2 times 2, 4. 4 plus 1. So class, see oxygen here, half plus 2 is 2, 1 over 2. Same thing as 5 over, so that's plus 5 over 2O plus N plus what? N2. Class, after adding up the three equations, anybody that appears the same here and here, let them cancel. So who is cancelling who out? N2 cancels N. 5 over 2O2 cancels over 2O. Who is now remaining? 3NO2 plus H2O to give what? NO plus what? 2HNO. Class, does this exactly look like our question? Yes, meaning you have done something right. You have done something. You see that the more examples you're taking, the better you'll be. Definitely, practice makes. Since you have confirmed, class, in the exam, you should be so good that you know you have arranged very well. You don't even waste time confirming. There's no time. Your exam is subjective. Just write your final. You should get to a stage whereby you are now so good in solving HESS law that you don't need to waste time to go and confirm if you did it well. Because it's waste of time. Because nobody will mark you. There's no mark for this in the exam. It's your personal problem. Lecturer looking for the final answer. It's subjective, just dash. Nobody's marking your steps. It's subjective exam does not require your steps. Just put in your final. So class, you can see that this reaction, our three, when we rearrange the equation and add it together, it gives us the desired. Class, if you can add these three equations to give this reaction, does it mean we can also add up the enthalpy change to get the enthalpy change of this reaction? Yes. So therefore, since these three reactions can be added to give this reaction, we can also add up the enthalpy change to give the enthalpy change of this. Let us now get, because the main question says calculate, please follow me. Main question, calculate the enthalpy change for the reaction below. That was the main question. Everything we have been doing is to calculate the enthalpy change of this reaction. To get the enthalpy change of this reaction now, we're going to add up the enthalpy change here, plus, but we have now confirmed that these three reactions can be added up to give this. So change in H for this reaction class will be minus 173 plus 108 minus 298. Oh, someone has done everything. Minus what? Minus 363 kilojoules. Minus 363 kilo. Wonderful class. Well done, class. Class, are you now confident enough for your own class work? Yes, sir. Let's take a class walk. Okay, please. Show everything in board one more time, then stop it. Show it very well in board one more time. So you can see the solving. When I did the class work, we start again.